Hello again, welcome to another lesson in Algebra 1. Today we are covering section 9.5, factor trinomials with a leading coefficient of 1. So we'll talk about this, what this means in just a minute. And we haven't said this in a while, so if you haven't done your warm-up yet, please pause the video, do the warm-up, and then come back and check. You're not doing yourself any favors by just copying down the answers. Your test is coming up soon, and you want to make sure that you can do these problems. All right, so solve each equation. Number 1, 2x squared plus 5x equals 0. So remember we want to set our equation equal to 0 and then do some factoring. So on the left side, we can factor out an x. That leaves behind 2x plus 5. And now we have two expressions multiplied to make 0. Remember, expressions are just take the place of an unknown number. So that means these two numbers multiply to make 0. So one of them must be 0. So either x needs to be 0 or 2x plus 5 needs to be 0. And then you solve this equation. So 2x is equal to 5 and x is 2.5. So here are our two answers. This is a quadratic equation. It has x squared in it. And quadratic equations almost always have two answers. Number 2, first you factor out 2y. And that leaves behind y minus 4. Okay, it was already equal to 0, so all we have to do is factor the left side so we can change this into two things, multiply to equal 0. And that lets us do our trick of splitting this into two problems. So either 2y is 0 or y minus 4 is 0. And then we solve these two problems separately. Okay, so here we divide by 2 to get 0, or over here we add 4 to get positive 4. So here's our two answers. Number 3, we have a problem. We can't do any factoring here because first, whenever we have a quadratic, so m squared or x squared or whatever it is, we have to set our problem equal to 0 first. So we're going to move the 6m over to the left side with the m squared. And then I can factor out 2m. It leaves behind 4m minus 3. And then we split this into two problems. 2m equals 0 or 4m minus 3 equals 0. So that means m could be 0 or 4m could be 3. So m could be 3/4, which is just 0.75 if you like decimals better. So here are our two answers, 0 or 3/4. Okay. Lastly, we have set this equal to 0, so we have 0 equals 22x squared minus 11x. We divide both sides, factor out on the right side this time, 11x, and that leaves behind 2x minus 1. And then we split this into two problems. So 0 is equal to 11x, or 0 is equal to 2x minus 1. That means x could be 0, or 2x could be 1, so x could be 1/2. All right, so let's flip it over and learn some new stuff. All right, on our second page, we have factoring trinomials. So we know what a trinomial is. It's 3 terms. And the ones that are going to be factorable for us are mostly going to be quadratics, which means they're going to start with an x squared, just like they did in our notes last time and what we saw in our warm-up above. Except now it's going to have a middle term of x and an ending term that's a constant usually. So factoring trinomials have a leading coefficient of 1. That means we'd have x squared plus 8x plus maybe 10 or something. Notice there's a 1 for our leading coefficient. We don't write it there. Okay. It's like solving a math puzzle where you need to guess two numbers that add up to one number and multiply to another number. For a good explanation of why this works, see Khan Academy math video, factoring quadratics x plus a and x plus b. He does a great job of explaining it if you really want to watch and see why this works. All right, so here's an example of what I mean. Say we wanted to factor the trinomial x squared plus 5x plus 4. In this case, you should ask yourself the following questions. What are two numbers that multiply to 4 and add to 5? Okay, so we get this from the general form of a quadratic, except ax squared plus bx plus c. And since when a is 1, we can put the c and b directly in here. Okay, so the answer to this is two numbers that multiply to 4 and add to 5 are 4 and 1. 1 times 4 makes 4, and 1 plus 4 makes 5. Therefore, the trinomial x squared plus 5x plus 4 can be written as a product of two factors, x plus 4 and x plus 5. So we're going the reverse of FOIL. So we learned FOIL to put it together, and now we're going to unfoil just like we undistributed in last time's notes. Okay. So remember, an algebraic expression like x squared plus 5x plus 4 just stands for a single number once we choose a value of x. So if we chose x as to be 4, or any other number we wanted, okay, just picking a random number here, then we do 4 squared plus 5 times 4 plus 4. This would add up to 40 when I'm done working it out. So if I chose 4, this expression takes the place of 40. Then the value of the expression is 40. Also, 40 can be factored into the products 8 and 5, because two things that multiply to make 40 are 8 and 5. Notice that 8 and 5 are the values you get if you replace x into our factored form. So if I put 4 in here, I get 8 times 5. So what it did is, no matter what value of x I pick, it finds two numbers that multiply to make that x. Okay? Can every number be factored into a product of two whole numbers greater than 1? So like 2, for instance. 2 has the factors of 2 and 1. So no, that doesn't work. 3 has the factors of 3 and 1. That doesn't work. Those are the only factors for 3. 4 is the first one that does work for us. 4 has the factors of 4, 2, and 1. So we could do 2 times 2. The ones that don't have it, okay, so this answer is no. And the ones that don't have it, their special name of that kind of number is a prime number. Okay, so you learned about the prime numbers in grade school. Those are the ones that have only two factors, one in themselves. Okay. All right, let's flip it over and practice some of this factoring of trinomials. All right, on our last page here, we have factor each trinomial if possible. If not, then write prime. So for our first one, we want two numbers that multiply to 2 and add to 3. Okay, and those two numbers are 2 and 1. 2 times 1 makes 2, and 2 plus 1 is 3. So we could factor this into x plus 2 and x plus 1. All right, so this is all we're asked to do. Just factor it. That's our answer. Remember, though, you could always check yourself on a quiz or test by just doing FOIL, putting it back together. So first would be x squared. Outside would be 1x. Inside would be 2x. And last would be 2. And we could see when we combine the like terms in the middle, we would get exactly the same trinomial. So you can always, always, always check yourself. All right, number 2. M squared plus 7m plus 10. So we want two numbers that multiply to 10 and add to 7. All right, so those numbers are going to be, let's see, well, things that multiply to 10 are 1 and 10 and 2 and 5. 1 plus 10 would make 11, and 2 plus 5 would make 7. So it's going to be 2 and 5 for our answer here. So this would factor into m plus 2 and m plus 5. All right, number 3. We want two numbers that multiply to 14 and add to 8. And those numbers are going to be, let's see, well, 1 and 14 won't work. They'd add to 15. 2 and 7 don't work. That would add to 9. And then 3 doesn't divide evenly into 14, and 4 doesn't divide evenly into 14. So we've used all the factors of 14, so this is not possible. So our answer here is, prime. Okay, this is a prime trinomial. Okay, can't be factored. Number 4. We want two numbers that multiply to 8 and add to negative 6. Okay, so let's see. If they're going to multiply to a positive number and add to the negative, then both of them better be negative. So now we can just think about 8 for a second. Things that multiply to 8 are 1 and 8 and 2 and 4. 1 and 8 would add up to negative 9, but negative 2 and negative 4 will add up to negative 6. So this is going to be n minus 2 and n minus 4. Okay. All right. Number 5, y squared plus 2y equals minus 15. So we want two numbers that multiply to negative 15 and add to 2, and that's going to be 5 and negative 3. If I want them to multiply to a negative number and add to a positive number, then I need one of them to be positive and one of them to be negative, and I need the bigger one to be positive. So 1 and 15 wouldn't work, but 3 and 5 work as long as I make the bigger one be 5 and the smaller one be negative. Okay, so negative 3. So this is going to be y plus 5 and y minus 3. Okay, our last one. We want two numbers that multiply to 64 and add to 20. So if I tried 1 and 64, that would add to 65. 2 and 32 would add to 34. 3 doesn't go evenly into 64, but when I get to 4, it's 4 and 16, so that works out just fine. They add up to 20. So we're going to write this a little bit different. It's going to be p plus 4q, because I need a q squared at the end, and p plus 16q. So q times q at the end is going to make q squared, and in the inside and outside I'm going to get pq, which is what we want for the middle term up above. Okay. All right, so this concludes just the factoring part, but obviously we're doing that for a reason, and that's so we can solve when we have a trinomial equal to 0. So we've already factored this one before, and we'll use our trick from last time. We have a single expression equals 0. If we change that into a product of two expressions equal to 0, then we can use a trick here. So our product is going to be x plus 1 and x plus 2. So in other words, we're factoring the trinomial. This is the same as number 1 up above, so if you're unsure of how I factored that fast, just flip back to number 1 and watch again. Okay. And then now we have two numbers multiplied to make 0, so either our first number is going to be 0, or our second number is going to be 0. And then we solve for them. So x could be negative 1, or x could be negative 2. Okay. All right, and number 8, same thing. We've already factored this one up above, so we knew this was m plus 2 and m plus 5 equal to 0. Notice in both of these cases, we already have equal to 0 on the right side, so if we didn't, as you will in your classwork next time, you're going to have to set it equal to 0 first. So now I can split these two expressions up because I know one of them must be 0 and solve for them separately. So m could be negative 2 or m could be negative 5. All right, number 9, find the zeros of each function. So we did finding zeros a long time ago when we just had linear functions. It's the same thing. Finding 0 means pick the t that makes this equal 0. Okay, so we can kind of scratch off that and just solve like we've been doing before. So we're going to factor this. So two numbers that multiply to 12 and add to negative 8. So we know they both have to be negative. So 12 and 1 wouldn't work. That'd make negative 13. But negative 2 and negative 6 do work. So this is going to be t minus 2, t minus 6 equals 0. And then you split this into two problems. So t is going to be 2, or t will be 6. And that means the zeros are 2 and 6. All right, so what does that mean again, zeros are 2 and 6? That means if I plugged in 2 into this function, f of 2, then that would be 2 squared minus 8 times 2 plus 12. And if I work that out, I'd get 0. So it's just saying what value of t can be plugged in so that the whole thing makes 0. All right, so we're going to do the same thing for this last one here. We're finding 0, so we'll just set it equal to 0. We'll factor this. See, two things that multiply to negative 20 and add to 1. So we know one of them's got to be negative and one's got to be positive, and the bigger one needs to be positive, so I'm going to use 5 and negative 4. Okay, so m minus 4, m plus 5 equals 0. Split this into two problems. M minus 4 equals 0, or m plus 5 equals 0, and then you solve for m. Okay, oops, that means the zeros are 4 or negative 5, or 4 and negative 5. Okay, All right, that concludes today's lesson. We'll practice this next time. Notice we have Khan Academy down here, factoring quadratic with leading coefficient of 1. It's due the day after our next class. And once again, these are all special ones because in each case, we always have a leading coefficient of 1. When that is not the case, we'll have a little bit more work to do, but we'll learn about that next time. Okay? All right, see you in class.